Let's do another example of solving a non-homogeneous linear differential equation with constant coefficients. And the left-hand side is going to be the same one that we've been doing. The second derivative of y minus 3 times the first derivative minus 4 times the y is equal to, and now instead of having an exponential function or a trigonometric function, we'll just have a simple, well, it just looks like an x squared term, but it's a polynomial, right? And you know how to solve the general solution of the homogeneous equation if this were 0. So we're going to focus just now on the particular solution. Then we can later add that to the general solution of the homogeneous equation to get the solution. So what's a good guess for a particular solution? Well, when we had exponentials, we guessed that our solution would be an exponential. When we had trigonometric functions, we guessed that our solution would be trigonometric. So since we have a polynomial here that makes this differential equation non-homogeneous, let's guess that a particular solution is a polynomial. And that makes sense. If you take a polynomial of, and actually a second degree polynomial, if you take a second degree polynomial, take its derivatives and add and subtract, you should hopefully get another second degree polynomial. So let's guess that it is ax squared plus bx plus c. Well, what would be its second derivative? Well, its second derivative would be 2ax plus b. And then the third derivative, this is the first derivative. The second derivative would be 2a. And now we could substitute back into the original equation. We get the second derivative, 2a, minus 3 times the first derivative. So minus 3a, oh no, sorry. Minus 3 times this, so minus 6ax minus 3b minus 4 times the function itself, so minus 4ax squared minus 4bx minus 4c. That's just 4 times all of that. That's going to equal 4x squared. Now let's group our x squared, our x, and our constant terms, and then we could try to solve for the coefficients. So let's see. I have one x squared term here. So it's minus 4ax squared. And then what are my x terms? I have minus 6ax minus 4bx. So let's say plus minus 6a minus 4b times x. I just added the coefficients. And then finally we get our constant terms, 2a minus 3b minus 4c. So plus 2a minus 3b minus 4c. And all of that will equal 4x squared. 4x squared. Now how do we solve for a, b, and c? Well, whatever the x squared coefficients add up on this side, it should equal 4. Whatever the x coefficients add up on this side, it should be equal to, well, it should be equal to 0, right? Because you can view this as plus 0x, right? And then you could say plus 0 constant as well. So the constant should also add up to 0. So let's do that. So first, let's do the x squared term. So minus 4a should be equal to 4. So minus 4a is equal to 4 is equal to 4. And then that tells us that a is equal to minus 1. Fair enough. Now, the x terms, these minus 6a minus 4b, that should be equal to 0. Right? So let's write that down. We know what a is, so let's substitute. So minus 6 times a, so minus 6 times minus 1. So that's 6 minus 4b is equal to 0. So we get 4b. I'm just putting 4b on this side and then switching. 4b is equal to 6. And b is equal to 6 divided by 4 is 3 over 2. And finally, the constant term should also equal 0. So let's add those. Let's solve for those. Well, 2 times a, that's minus 2 minus 3 times b. Well, that's minus 3 times this. So minus 9 halves minus 4c is equal to 0. So let's see. I don't want to make a careless mistake. So this is minus 4 minus 9 over 2, right? Right. That's minus 4 over 2, minus 9 over 2. And then we could take the 4c, put it on that side, is equal to 4c. And that's what's minus 4 minus 9? That's minus 13 over 2. So minus 13 over 2. Right, minus 13 over 2 is equal to 4c. Or c, divide both sides by 4. And then you get c is equal to minus 13 over 8. Minus 13 over 8. And I think I haven't made a careless mistake. So if I haven't, then our particular solution we now know. And actually, let's just write it in well, let me write the whole solution. So, and this is a nice stretch of horizontal real estate. So let's write our solution. Our solution is going to be equal to the particular solution, which is ax squared. So that's minus 1x squared. So minus 1x squared, right? Ax squared plus bx plus 3 halves x plus c minus 13 over 8. So this is the particular solution. We solved for a, b, and c. We determined the undetermined coefficients. And now if we want the general solution, we add to that the general solution of the homogeneous equation. The general solution of the homogeneous equation, what was that? Y prime minus 3y prime minus 4y is equal to 0. And we've solved this multiple times. We know that the general solution of the homogeneous equation is c1 e to the 4x plus c2 e to the minus x, right? You just take the characteristic equation r squared minus 3r minus 4. You get, what did you get? You get r minus 4 times r plus 1, and then that's how you get minus 1 and 4. Anyway, so if this is the general solution to the homogeneous equation, this is a particular solution to the non-homogeneous equation. The general solution to the homogeneous equation is going to be the sum of the two. So let's add that. So plus c1 e to the 4x plus c2 e to the minus x. So there you go. I don't think that was too painful. The most painful part was just making sure that you don't make a careless mistake with the algebra. But using a fairly straightforward, really algebraic technique, we were able to get a fairly fancy solution to this second order linear non-homogeneous differential equation with constant coefficients. See you in the next video.